Oh, I'm already supposed to start?
Okay, so we're anytime.
Sorry about that. All right, my name is Michael Nugent, and I recently converted a report that I did for school into this presentation, which wasn't as easy as I thought it was. I don't like PowerPoint or Impress in this case. What I want to address is the technology standards as they appeared predominantly in the Ohio Education's technology standards documentation. But what I want to focus on mostly is how and why have these technology standards failed to address computer science. And by fail, I don't mean not attempted. I mean, I mean failed in terms of not attempted, not in terms of they tried but failed. There's things that are just missing. And then how and why should the technology standards be improved? Now, this is what I want to focus on predominantly. The standards, education standards, are produced by each state, but usually closely reflect the national standards. As far as I can tell, without doing a word-by-word comparison, they're almost identical. They're long documents written to be general, yet encompassing providing a guideline for a curriculum that teachers would use in their classes. Whole portions of it, it's like the entire thing is rewritten 3 times. Whole portions address it from a different perspective, from the teacher's perspective, from the standards perspective itself, and also from the student's perspective. And the intent there is that teachers then will be able to get a better perception of what they're supposed to do. However, in all this, the teachers are able to exercise some creative latitude. The technology standards specifically, the ones that I wanted to address, are produced by an outfit called ISTE, which is the Standards in Technology and Education Department, and that's the national one. And that template is used also in the national. They use it in the state standards as well. The benchmarks for the technology are not as honed as the ones for math or science or social studies, for that matter. The contributors, though, seem aware of the lack of refinement because they meet rather often. Their minutes, the tone of their minutes for the meetings, they're different than the ones for the other areas, which are more like, what are we going to do next year to bring more attention to this? This is more like, how are we going to accomplish this? There's a few hopeful quotes in the technology standards, which is what drew me to them in the first place. Technical capabilities are important tools in preparing students for high-skill, high-knowledge jobs. This quote comes right from the technology standards, and if you've been to some of the other talks here today, there's a big concern about brain drain in Ohio, and so I certainly would agree with this. The second statement, though, the integration of technology into all content areas enhances learning and supports effective instruction. The issue here is that there's some research, substantial research, to indicate that this might not actually be the case. Trying to integrate computers into the classroom doesn't always produce the results that they'd like it to produce, the results being higher test scores, more aptitude, more interest in the subject matters. So my experience with this, in 2003, I willingly left BP rather than emigrating to Tulsa. I don't know if anyone's ever been to Tulsa before, but it's just not a very interesting place. BP is British Petroleum. It's the oil company. And this accelerated my plan to become a teacher. During this class, I was supposed to develop a lesson plan based on any of the standards. Well, I chose to explain algorithms and how we use them to third graders. Now, the research for this, the idea for this, came from some stuff that I read. Seymour Papert. Papert is a student of Piaget, who was educator in Switzerland at the time, and they did a lot of research into how children think, how children learn in particular. Piaget theorized constructivism, which is that knowledge is constructed internally and then tested against reality. And we watch kids do this. They think they know something and they want to find out what this now means to them. This is an effective way for them to learn, but that isn't the way most schools teach. And so Piaget formed this school of constructionist thought, and Papert was his best student. Well, Papert believed he developed a language called Logo, used to teach very young kids, as young as 4 years old, how to program, how to put their thoughts, how to put their processes into a procedural language. So I wanted to see that in action, not Logo itself, but just I wanted to see young kids doing computer stuff. So, why is that off there? So I reviewed the technology standards, but I couldn't find any benchmarks. These standards are broken down into areas that specify how you're supposed to address certain aspects of the curriculum. For instance, the term algorithm appears only in the definition of a term in the glossary. I don't remember what that term is right now, but programming is used to describe designing web pages, which isn't really programming. And for any web designers here, what I mean by programming is that HTML, which is meant to mark up text, is not procedural or functional or algorithmic. They're more descriptive languages, CSS and XML and things like this. So it's not really a way to compose your thoughts. So I gathered from the different parts of the technology standard with great interpretive liberty. I took this one, identify machines, and describe how these machines extend human capabilities. I figured, well, what the heck? I mean, I guess algorithms are machines in a way, in an abstract way. Solve a problem using iterative discovery. I stretched this to convey debugging for the most part. I thought this was the closest thing to debugging I could find. Address the economic consequences. Well, I mean, this we could potentially do. I thought we could consider improving economic development, but potentially in the compare and contrast way that it might reduce or limit the number of unskilled jobs that were available, as most automation does, software being no different. And then the third, I took parts of the standard 7 there, and these are the benchmarks. A2 is a benchmark in B1. Understand how machines and information are used to develop useful systems. Well, it sounded good, but I really wasn't sure how I could stretch this to apply to programming. I went through a couple of the other standards, the math and science ones, trying to see if I could find anything there, and there just wasn't. So there's no guideline for teachers to teach computer science, to teach any kind of computer theory or programming or algorithms to kids. So I figured that the technology standards fail in 4 obvious ways. One is misapplication. The benchmarks are presented just because they're designed to use a computer. Sometimes this could be completely like writing a term paper. It uses a computer. Well, we're going to call that technology. You could do that with a pencil, though. Social mandates. Benchmarks emphasize mores as if technology requires the emphasis. And this I'll get into a bit later. The glamour. Technology is used to bait or heighten student interest, as if it really needed to be done that way. And then underestimation of students' abilities is one of the foremost ones. So, misapplication. Technology standards introduce application software, not underlying concepts. Technology standards, in my first draft of the paper, I used card catalog as an example. I was suggesting that using a computer, learning a computer should be done in social studies. Using a computer to gather information should be done in social studies, where you can use card catalogs, but I didn't realize that most people probably haven't used a card catalog. Has anyone used a card catalog? Yeah? Oh, have they? Oh, I didn't even know. So I changed that to be something else in the term paper. There are research tools that are appropriate to social studies. And then one thing I should note, though, is that the technology standards are meant to intermingle in other courses. Like someone in social studies, like a social studies teacher, is supposed to implement the state's standards in technology also. My problem was more that I just couldn't find a place for my stuff to fit. The social studies one I just covered. Text justification. by the technology standards, should be covered by technology standards, whereas word processing, which is what it currently says in the technology standards, I think should be covered in like English class. Graphic standards, they talk about using a mouse to paint a picture. I think this could be done in an art class. The social mandates kind of bothered me, mostly because of the presumptions that they made. For instance, I don't remember addressing shoplifting in school. And I was in an inner-city Catholic school where you think that might have come up. But now we're bombarded with rhetoric about IP and piracy and the rest of these things. So I don't think technology demands any more adherence to ethics than chemistry, yet the standards direct students toward an imbalanced ethical use. I'm wondering if, for instance, anyone told A.Q. Khan that his use of mathematics and science was an immoral idea. I think that just as much damage can be done using any knowledge that we have. I don't think computers are in particular bad. The perspective is usually only from the IP owner. The curriculum, as it's stated in the technology standards, warns against infringement, but it doesn't discuss the rights of the students, the ones that they should have or did have and have been taken away from us. The Mickey Mouse bill, sponsored by Sonny Bono, it's the Copyright Term Extension Act, lobbied by Walt Disney. This was to protect their asset, basically, Mickey Mouse, from expiring and going into the public domain. So now we have basically indefinite limits on copyrights. Also, there's a blurb in a thing I just read yesterday that Arthur Adams received a complaint from the lawyers for Uncle Milton Industries of trademark infringement after using the term ant farm in a comic strip. Apparently, ant farm is not a generic term. It's a trademark. So he wrote, it became clear that as long as there's dirt and ants and glass and people who will pay money to see them pressed together, there would be money to pay a lawyer. So we have issues like this that need to be addressed. Under this curriculum, students are more likely to use copyrighted work than to produce one. But I think that that should be encouraged. I think that kids should produce those works. They should copyright them to understand their rights as a copyright holder. I also think that they should open those copyrights up, though, in terms of licensing. I'd like them to be open licensed. Glamour. The computer is considered a resource for learning in a rich multimedia environment, and this goes without saying, but not only does the technology get perhaps misapplied, but it gets the glitz that it doesn't really need. Kids already like new things, and software makes computers shiny and new every day. Technology, though, has resurrected accounting, typesetting, photography, and typing lessons. Things that we haven't done in ages now have started to become popular again, like kids are balancing their checkbooks and stuff like this just because there's software that provides that, and the teacher really can't think of a better lesson, I suppose. I'm not sure. Underestimation. Papert studies and those of many of his students show that children can learn at ages as young as 4. The transition in a single grade from applying simple technologies to creating simulations without supporting concepts in lower grade, this really isn't so much a way that they underestimate. Perhaps this could be an overestimation. They're supposing that suddenly in this particular grade these kids become knowledgeable of how to do programming, but that really doesn't help because they're missing. The teacher's not instructed how they're supposed to get to that point in the first place. They first imply technology theory in the 4th grade. In the 6th grade, they suggest that they have a lesson that uses technology to organize data. In grade 7 and 8, they recommend technology to investigate data and present conclusions. And then in 8th grade, they recommend creating these simulations. Now, without some sort of underpinning, without some ability to model using computer languages, I presume they must be talking about using things like SimCity, which does require some thought and programming as well. And I'm not averse to that, but I would still love for them to be able to model their own ideas in their own way. Boolean expressions aren't mentioned until the 9th grade. And this actually came directly from the science standard. Quite a bit of the technology standard came from a section in the science standard called Science and Technology. So programming finally appears in grade 12. In the design section, the benchmarks deal with tools and construction materials, but there are no obvious benchmarks for computer technology. Algorithms are both tools and materials. This is, as I said before, this is where I stretched the standard to suggest that algorithms really are machines, but they're software machines. The problem is that if I'm going to try and teach algorithms to third graders, and this isn't presented until the 12th grade, I'm probably going to end up stepping on some toes or getting some parents worried or something like that. So why do they have these problems? Well, I think technophobia is one of the biggest ones. This is another quote from Papert. Humans learn a balkanized image of human knowledge separated by impassable curtains. And basically, we end up limiting ourselves constantly just by our presumption that we shouldn't go past a certain barrier. Books guide us through the mystery of computers, describing contraptions and gizmos. This is all, makes it all very mysterious. They imply that computers aren't a part of our daily lives. These days, almost everybody, with the exception, I suppose, of some older people living at home, don't know how to program their VCRs. Glamour is added artificially to interest the student in technology, frightening to the teacher. I think this is an issue with perspective as well. The teachers are fearful of this, and so we presume that the child will be too. You watch parents worry about their kids, even though the kid is perfectly fine walking across that I-beam, you know? Like in the Warner Brothers cartoons. Desire for immediate results, I think, derails the technology standards potential. They obviate the purpose of the lessons. They make the lessons suggest that this is what you're supposed to learn instead of finding out what the kids can get from these lessons. So when I was doing this paper, I wanted to find out why I was missing on so many points, and so I investigated the other standards. The technology standards use technology to study other subjects, and this was a bit unique to the technology standards. I didn't notice this in the other areas. Nothing in the science standard, even the science and technology, dealt with computer science at all. The math standard mentions algorithms in grade 5 onward, but more as a means of solving equations. And grades 11 and 12 talk about constructing algorithms for multi-step and non-routine problems. Now, this begins to get to it, but the whole focus there is on mathematics and not solving other problems. And then the other curiosity that I incessantly found was that neither science nor math, the standards, involved any mention of ethics whatsoever. Improving the technology standards, then, is the gist of what I wanted to come here for. I wanted to mostly point out in what follows that computers really aren't typewriters. They shouldn't merely support learning, but should themselves be studied. And that computers are uniquely qualified to broaden education and enhance interest in a competitive and marketable area. As the standard said at the beginning, those hopeful quotes, they really know that technology is going to be the wave of the future and that people should be learning this stuff, but they're not. We don't have a place for it, really. So instead of misapplication, I want to apply these things. And computer science embodies general methods for learning and problem solving. I think it is appropriate, actually, for many subjects because of its flexibility. Like math or computer science, computer science supports other disciplines. Programs can conjugate verbs in a foreign language, the oasa amosan in Spanish or something like that. Diagram English sentences. Logically diagram arguments in a debate. That doesn't happen until high school, I suppose, but and then extract and analyze data in a social studies or science class. There's also art examples. There's lots of places that technology can be used. The fundamental ideas behind computer science can be used, but I don't think that they achieve that in the standards themselves. Another big issue is the social freedoms. Teachers and students should be aware of the abundance of patent-free or copyleft technology in media, and this became more apparent to me a little bit later. I'll show you a slide. The EFF, if anyone, I think most of the people here have probably heard of it, and also the Free Software Foundation are dedicated to freeing media and software from innovation, or for innovation and study. Ibiblio hosts Project Gutenberg, which digitally catalogs 10,000 books in the public domain. This is a great place to find things like Grimm's fairy tales, the original version of Dr. Dolittle, if you really want to spark some debate about censorship. The technology standards recommend students insert copyright-free images into multimedia presentations. I thought this was a bit interesting. This is one of these examples where they're emphasizing something I don't think needs to be emphasized. And that's a direct quote from that. So what they didn't mention, though, is that GIF was patented until it just finally expired. And JPEG's been controversial ever since the patent claim against its compression algorithm. PNG, however, which they don't mention, is patent-free and open format. Not only can PNGs be used without concern, but the associated algorithms can be studied. The libraries, or the source code for the libraries, is all over the place. In the very least, we can spark academic discussions for students to understand how the technology affects society around them. I want to de-glamorize computers. Computers are regarded as addictive already, but while school is not, and this isn't because the technology is, isn't boring. It's not because the technology is cool. Papert attributes a child's affinity for computers to the computer's ability to create an environment that nurtures self-development. Another quote from one of his books is that children are at risk because they do not have access to a wide immediacy for exploration and have only limited sources that they can address for questions. Oh, and there's an important note on that one. Glamour is not necessary to entice children because children's disinterest with learning proceeds from a limitation on how immediately and effectively their inquisitiveness can be sated by their own effort. That's basically a restatement of that. Esteem. A child builds his or her esteem by being comfortable with his or her own knowledge and abilities. Consider the farm children who kept old tractors by ingenuity and tinkering. Papert wonders whether the opacity of modern machines is a danger to the learning environment. And as I've stated before, I believe that this is so. And the Free Software Foundation is encouraging people to open these ideas up so that we can study them more openly, more freely. Children have the ability to understand new concepts in technology while very young. We just don't give them credit for it in general. The standards shouldn't hide from students the power of the computer under the veil of applications, which is what my biggest concern is with most of the technology standards, where they're showing kids how to use spreadsheets and things like this without showing them the underlying principles. In a book, Children and the Internet, research put an English language kiosk in a Delhi ghetto, New Delhi, like in India, where none of the inhabitants had any exposure to computers or understood much English. But within a few days, 5 to 16-year-old kids were using this kiosk to do browsing. They even discovered that there was a camera hidden in the thing and disabled it and sent an email to the researchers saying that they shouldn't be spying on them. And then the other interesting point is that in this entire 3 months that kiosk was there, not a single adult went near the thing. So the computer science would stimulate students to think about how they think. And children who understand themselves and can answer their own questions are empowered and worthy of our esteem. I would ask the questions like, how do you put your pants on in the morning of adults? And the initial response is, well, what do you mean? Isn't it obvious how I put my pants on? But as I begin to get deeper into the questions about how they put their pants on, they realize my intention, and that's to break things down into something very small, where they're realizing that they've actually followed a procedure. There's a disclaimer on this because of the initial critique in the beginning. The ISTE, which I said was the publisher of the technology standards, they also sponsor a lot of other books. One of them was Ideas and Strategies for the One Computer Classroom, which I think is extremely appropriate, the contents of it. It's good because the lessons are taught at very young ages on a variety of topics. And because it's designed for a one-computer classroom, the lessons show that computer science is more abstract. Computers are necessary only to examine the outcome. So these kids could get together into these groups, they could write their programs, and then go and put the programs in. And I don't think anyone in the room is old enough for this, but in the good old days, that's even before my time, you used to have to do that on the mainframe. They do batch processing. The programmers work all day long punching Chad out of these cards, and then at the end of the night, they'd all get their time, and they'd go and throw these in. Well, kids could do the same thing, and I think they get more out of it because it's going to involve more thinking then. They're not just going to keep typing, running, breaking the program and coming back to it. And I think as adults, we can do this too. I see a lot of paper wasted where I work because people just keep printing out buggy programs. I thought I had some more notes on these, but the blurb that was on the website for NOTACON, I think, covered this, but it's worthy of emphasis. If education is to advance to the next generation, students must study the underlying concepts and improve them, to build on them and breed them together to form hybrid constructs to solve the problems of their day with significant data of their day. Papert wrote a parable of some teachers that went back in time, some teachers from the future that went back in time, because we don't have a time machine now, we only have one in the future. So they went back in time and went to a classroom, and they did not know what was being taught, but they understood the need for the teaching, and they understood the patterns of the teaching. So we don't know what they're going to need tomorrow. To teach them anything today, everything that I learned in school, now as a computer programmer, I've completely outgrown most of that, with the exception of the master's that I took, and I don't really even remember most of that now. But they can't build a better database engine if they're just using front ends. And they can't develop faster methods for using prepackaged spreadsheet formulas either. They need to understand more what's underneath the hood. There's a few things that I missed when I was throwing this thing together, and I wanted to get more notes on it, but I thought that I wouldn't have time. As it seems, I'm probably, it's a good time, I guess. There's a lot of research that shows that this, and there were a few other speakers that covered this earlier too, that when you open these ideas up, suddenly they become the whole world's resources, and you have to make yourself more significant. You have to stand out in other ways then, not just by using that technology. And so as far as resources go, it's something that we can take advantage of. Learning science teaches students how to think about the world. Show students respond best when instruction is personalized and when the lessons are self-taught. This is really crucial in the schools where the student-teacher ratio is high. When you don't have a lot of students, or when you don't have a lot of teachers, when you've got too many students per teacher, a lot of students get relegated to the side. You know, they begin misbehaving. Well, if these guys are engaged in something, if they're teaching themselves something, then they probably won't be as troublesome. And they'll likely be learning something rather than getting into trouble. Also, there was some stuff on homeschoolers that I found. And I want to acknowledge that a lot of those websites are very good. And then one thing I didn't cover in the the area about trademarks is that Microsoft is giving a lot of their software to schools, but then they end up, on occasion, some rare occasions, some pointed occasions, suing these schools because now they're free software, they didn't upgrade it, now their licenses have expired, and so I think that using these proprietary software applications, instead of either doing their own stuff or getting something from the Free Software Foundation, using Linux, using open source software, it becomes precarious, it becomes dangerous for these schools to do this. Because they're going to end up in a spot like this, potentially. There was a graph also. There was a graph also, and I didn't even write this down as something I should cover if I get done quick enough, but there's a bunch of research that was done on both minorities and also females. In general, it's thought that women aren't interested in math and science subjects. There's been considerable research showing that they can be, depending on how it's presented. And again, as teachers, most of these teachers, especially coming from old schools of thought, they're presenting this material to these students in a way that we as adults communicate. Even adolescents begin to think differently than children do. Well, this research that they've done with Papert at the MIT Education Labs is that because if you teach kids the way they learn, if you teach to their learning abilities, they are capable of learning all this stuff. And then the same goes for minorities and also for women, or girls in this case. If you present this material in a way that doesn't immediately turn them off, if they can relate to something immediately, then they can develop a love for learning this stuff in the end. I also brought some materials, and in fact, on the way On the way here, I picked this up, and this was just today. And this article was about the software companies again. I should have mentioned that with the Microsoft stuff. And it's basically, I mean, you got this flim-flam guy here with the mustachio, the greased mustache. And he's selling software, basically. A lot of the software that I see in schools, it's got a ton of glitz. It doesn't have much substance. It doesn't teach kids in a way that the teachers can't already teach them. There was another example. Papert was observing a classroom, and this one particular kid kept getting reprimanded by the teacher for not finishing the problems correctly. He apparently discovered that the sounds and the images that popped up when he failed to get the correct answer were more entertaining to him than when he got the right answer. And so he was choosing, actually, to do the wrong thing just because of the reward that he was getting from it. I've actually noted that a lot of computer programs are getting better about that, where if you get something right, there's a lot more fanfare, and if you get something wrong, it's just a really quiet little buzz. And this is a good way to do things like that. There's a bunch of resources. I already mentioned a Biblio. There's Python for Fun. CP4E is actually computer programming for everyone. I don't know if any of you program in Python, but Guido van Rossum developed it using ABC, a language, a teaching language, as a template. And he never intended for Python to be a teaching language per se. He meant for it to be more functional, but he got so many letters from people who hadn't even discovered ABC at the time that Python was a very effective tool in their classrooms that he began this project, which is the Computer Programming for Everyone project. There's a public knowledge website. There's also Open Government, which I didn't put on here. Think Python and Wikipedia. I think we've all used Wikipedia by now, and that's just growing at a phenomenal rate. This is a good place to find information on the actual productivity of using computers in the classroom. The MacArthur Foundation, spends a lot of money making sure that computers in classrooms are effective and measuring which ones are, which ones aren't. And this is the website for them. A lot of those reports are publicized on the web. I forget this exact report. I think she's another student of Papert's, Dr. Margaret Kirkwood. Almost all of them, Papert was Piaget's finest protege, and after him, almost everyone has come from that school at MIT, plus a few at Carnegie Mellon, I think. And the network guy, Vladis, that was here a couple nights ago, I'd love to see. There's a website called Math Genealogy, or Genealogy of Math, Genealogy Tree, and it shows how all the mathematicians are interrelated, like currently living ones or recently dead ones, how they all interrelated. And yeah, I think that's all of it. So, any questions? Any criticism? Because I hope to give this at some other time. I needed a lot of slurring. I just printed these notes today. Just got this computer at the beginning of the week because I couldn't stand the idea of doing this on Microsoft Windows.
I wanted to go back to a real general note. In Michigan, how's this? Okay. On a real general note, in Michigan, there's been this Laptops in Schools initiative where they're spending a great deal of taxpayer money putting laptops or threatening to put laptops into middle schoolers' hands. And, you know, on its face, that's not such a bad idea. You know, kids should have computers to play with. But what I see wrong with the problem, or wrong with the program, is that they then rely on these machines. They can't take them apart. They can't mess with the software. They can't do a lot of programming and things like that, because if they screw it up, well, now they can't do their classwork and so on. And, you know, a mechanic has two cars. There's the daily driver and the project car. And if you expect kids to learn how a computer works, that can't be the one they depend on. And that's what I see so many, computers and kids programs screwing up, is they say, simultaneously, you should learn all sorts of things about this machine, but don't you dare play with it because you might break it. I was wondering if you could comment on that.
Definitely. There is a lot of research that suggests that it may be a waste of taxpayers' money even if they don't ruin the computer. And even at Cleveland State, I mean, the kids aside, even in Cleveland State, they've got a computer loan area. And I noticed some kids going back weekly, basically to get their hard drives re-imaged. I don't think they'd have that problem if they were using something besides Windows, but they might. I mean, they can screw that up too, I suppose, especially if they're developing. But I almost think that that's the point of having any tool, and especially if you're going to send it home with a kid where he's going to work with this thing in private, he's going to want to play with it. I would encourage them to take it apart and ruin it for the most part. The One Laptop Per Child project that Negroponte sponsored underwent a lot of criticism. There's still debate whether it's going to work or not. For anyone who isn't familiar with it, they're looking to sell laptops to third world countries at $100 a pop for the most part. Now, the initial countries that got involved, like Brazil, Nigeria, and a few others, they're actually paying more like $175, $200 for these things. All of the politics aside, whether it's right or wrong, I see merit in it. I see some things that are a little bit hazardous, but those things are designed to be basically wrecked. They've got a reset button on the bottom, just like your PDA does, which is going to reset that thing from flash. They can do whatever they want with this. They can take it apart a million different ways, ruin it a million different ways, and just reset it. You know?
Okay, back again. And in that respect, they're very much like the computers that I think we in the room learned on. Our generation, started with the Commodore 64 and the Apple II, where there wasn't a hard drive. You turned it back on, and it was back to its new state.
Or a tape.
Yeah, okay, Sinclair. Yeah. But that general era of machine was a lot more forgiving. It was much harder to screw it up. You had to have a screwdriver to do any lasting damage to that machine, and of course I did. But I learned.
Well, see, back in those days, it's interesting. Now, it could be that just the people that are in this room are the ones that were able to fix those computers when they ruined them, which is why we're all here today. And the people that broke them never got another one, probably, and they're not here.
but I think that people.
But the other aspect might be that there was no one then to criticize what you did with the computer. Teachers had no idea. They still barely have an idea. They just want you to treat the laptops they give you gently, So we did a lot of hacking in those days.
But I wonder if is there something about modern machines and modern, complicated OSs, the kids getting their drives re-imaged every week, is there something that simply you can't learn the way we did on modern machines?
Well, I would think so. As a systems programmer about 10 years ago, computers have gotten very, very complex. I think at this point, there's probably very few hackers that know the entire system. Like I used to know the entire interrupt, all the interrupts for the DOS operating system, for instance. I can't do that stuff anymore. Systems are too heavy. There's too many applications, too many mechanisms for communications. And that's good in a way, but you're not going to be good at all of them. So I think that that's an advantage, because now if I don't have an interest in GUIs, I can still work on transport layer stuff. But if I don't like the low-level stuff, I can work on the GUIs. That code is there now, and it's better documented, and it's easier to work with. Well, the One Laptop Per Child, for instance, the entire thing, even the file system, is written in Python. So when the machine crashes, you see a stack trace. You get to see exactly what happened, and you can reprogram the file system. So,
do you think there might be some merit to simple machines like that, whether they be a lab full of retro Commodores and Apples, or a lab full of One Laptop Per Child hardware here in the U.S.?
Sure.
Simply because it's easier to see how it works.
Well, I'd like to take anything and see how it works. I mean, when you dissect a frog, you're like working just on his respiratory system one day, or just on his whatever the next day. I think that you would need to focus on something in order to gain much out of it at all. But we still have those niche markets, or even niche interests today. We've got people that just do embedded programming. Now, it's not something I do. I'm not accustomed to a 4K barrier, but there's people that get off on that, and they're involved in projects that are always on something small, a single application running on a very small device. So I would think it's just up to your own interests. It's good that there's a variety that there is today. Not everyone wants to write assembler programs anymore.
Do you teach? Are you teaching currently?
No, I went back after I got laid off from BP. The year after that, I started in there's a master's program, an accelerated master's program at Cleveland State, and I just started that, decided this is what I want to do for the rest of my life, and the weekend before my finals, I got calls from 3 companies after being unemployed for a year. So I bit the bullet, went back to work for the man, and tried to pay off the mortgages so then I can go and become a teacher and not have to worry about mortgages. So.
It's been a while since I was in high school, but from what I understand, the district I went to is doing the same thing, where they threaten to suspend students who, in a programming class, write a program that was not specifically requested to be written by the teacher. What would you recommend can be done to try and convince a district to change policies like this, that restrict the ability of students to reasonably play around with the system in a class where they're expected to be, a class other people would expect them to be able to do stuff like that?
Not citing tons of material in this thing was tough enough for me to do, but that question will even be more difficult to answer in a politically correct way. I've always been a bit of a rebel. In religious classes, I would, if I disagree with the teachers, I'd frequently fail the test on purpose. And it's just as difficult to get a 0 as it is to get 100. So I would personally recommend a walkout of the students. I'd refuse to program under those circumstances. I don't even call that programming in that case. In terms of doing something effective, though, if a walkout wouldn't be effective, I don't know how many students are involved. I don't know. I would bring in my own laptop. Or I'd write a program that isn't on the computer. And if the teacher says, you know, well, that's not the assignment, you can say, well, you can show them that it is. It produces the same output. I mean, that's the wonderfully expressive thing about computer science that you can't do in mathematics. You can express yourself. It's almost an art form. So you could write it in a different language or using a different algorithm. So he could do that, show the professor that it works, show that the output is exactly the same, black box methodology of programming, and say, if the teacher wants, since I wasn't permitted to do it on the computer, you run this, you know, at your own leisure, make sure that make sure that the output's exactly as you expected, and if it is, I deserve the A.
Well,
I'd
okay.
say that.
It wasn't a matter of your program had to be written the same way. It was you had to only be working on creating a program that creates the output you're supposed to.
Right.
So if I finish the program early, I can't go and work on a separate program that I want for myself. But the other part of this question was, as someone who is out of school, someone who's graduated from college already and is back living in the same district again, what can I do as a community member to try and convince them?
Wow, I didn't even know things like that existed. It sounds kind of draconian, but
yeah.
I'd say talk to Strickland. I would bet he's got an open ear for stuff like this, especially since we want to make Ohio like a technology hub.
Michigan.
Oh, who's your governor? I don't know. What are his propensities?
It's a district thing, and it's not a school board.
Yeah, and I'll bet the governor doesn't have say.
So you can't vote the people out. It's the administrators in the school that you can't. You have no way of doing other than complaining to them about them.
Huh. Yeah. How about like Google Summer of Code? You could do your own like district-wide Summer of Code. Take all the lesson plans that the teacher had during the year and have them complete those like in a day just to show the prof up. I don't know. I mean, if the teachers were to rebel against that curriculum, and I can't fathom. I'd love to see the documentation. I mean, even though I definitely have my opinions, I'd have to think that they at least thought they had a good reason for doing that, because that seems awfully restrictive. Well, and that's been the case. Well, and they're scared of technology. I mean, like we were just talking about. Now, your parents, you know, if you sit down at your parents' computer, they're going to worry about it. Now, I've got a junker that Oscar can use. He still wants the newest. You know, I just bought this a week ago, and this is all he can think about now. So he can't eat on it, and he knows that. You know, but if you teach your kids respect, you know, within limits, and accidents happen. You know, definitely. How much stuff did I break when I was a kid? Ton. Exactly. That's Dad. Stuff he'd bring home from work, I would just completely disassemble. I don't know.
Being an ex-teacher in Ohio School District,
I found that, actually, and also in Illinois, it went for both in inner city Chicago and in the rural country school. The students were allowed to use the computers, but being that they were such an extreme expense to the school, they weren't allowed to use any outside disks, any outside little hard drives. They weren't allowed to go outside the lesson plans of the teachers. The teachers had their hands tied by the computer, as we called them, Nazis. Even in teacher meetings, the principal would refer to them as the computer Nazis. And the reason being is that everybody knew that those two people knew how to fix the computers if they broke, and otherwise that's the only way we could use them for lessons.
But the two that could fix them were the Nazis?
Yeah.
Oh, I see.
They pretty much controlled the computers in the school.
Yeah.
And this also went for when I was in Chicago. The people that, the technology, IT people, were in control.
Wow.
And they pretty much controlled what the students could do and what the teachers could do. And there was no way of letting the kids play.
I would suggest that this is even more reason that we should implement something like what I'm suggesting, if not this, something else, but basically grow this. I mean, we want to encourage hacking. We want to encourage expression. We want to encourage study, research, in-depth stuff. I don't know. I'd get involved with some of those install fests, I suppose, see if any big corporations can throw any hardware their way. Forget the laptops. And there's old laptops that'll run Linux too, but forget those. And pick up some desktops, put them in the school, or have like a week that you can put them at the school, rent a room at the school, throw them in there, and tell the kids to have at them. Have Linux boot, like just, the live CDs, have a bunch of those. And give them all USB keys. How much is a 16 meg USB key these days? You could put a lot of Python code or C code on a USB key. I'd say, I'd wholly disagree with that. And I'm not as involved as you guys are, and I guess that's unfortunate, but that's a direction that I'm going to head, certainly. And I'll talk to at least my local people about that. I'd love to know if that's a problem.
Okay, I recently graduated high school about 6 years ago. The curriculum we happened to have was you didn't actually start doing even the typing classes until you were a freshman in high school.
Yeah.
What's your take on stuff like that, where we didn't start programming, getting into even basic programming until our junior senior year, pretty much.
Like I mentioned in this report, I found it odd that computers are bringing back things like typing. These were, and the reason I believe that you learn these in your freshman or sophomore year of high school, as did I, is that back in the day, there used to be two directions you could take in high school. One was vocational, the other was college prep. And they wanted to make sure that you didn't become retarded in your senior year, and so they wanted to give you both vocational and college prep in the first 2 years, usually the first year. So you take things like wood shop and metallurgy and typing in your early years, I think, thinking that you might grow up to be a secretary or a court stenographer or something like that. These are vocations, though, I think, and that's why I don't believe they should learn a specific application. I think besides getting into proprietary stuff like with Microsoft, you run the risk of pigeonholing someone's knowledge.
Well, actually, that curriculum is actually still in place at that high school.
Yeah, I don't doubt it.
But there is hope, though, in that in the particular area I lived in, there's a counter school, which actually my particular school's direct rival. They actually started doing robotics classes.
Yeah.
So there is hope out there, I guess you could say.
I find that those are actually coming out of like metal shop type classes. They're trying to juice up metal shop, so they're throwing in some robotics.
Well, actually, in this particular school, it was actually straight. They don't have metal shop in that school anymore. They actually moved the vocational type classes like metal shop, industrial tech. They actually moved that to their 8th grade classes. In their freshman year, they start doing the typing as well. But it's when they moved into the sophomore year, they start doing the robotics classes, and they actually enter them in competitions instead of everything just being right there at the school. So they actually get it where it's regionally involved. So I mean, just just give you a little bit more information as what's starting to happen, how things are starting to roll, at least in the Trumbull County, Mahoning County area of Ohio.
I mean, there are quite a few schools around the Columbus area. There's a lot. I think Rocky River High, basically it's schools with cash that are putting together computer science courses. They are teaching them to program a little bit, but again, predominantly it ends up being a lot of web design, a lot of multimedia development and things like this. And I don't discourage that. And fortunately, someone in that class is going to write some back-end CGI stuff, or middleware, I should say, not back-end. But so, programming is not for everyone, certainly, but I would definitely want it to be introduced to everybody just to encourage people to think about how they think. And I think it would help with so many things. I mean, breaking any problem down into a smaller problem helps you to deal with it, whether it's dealing with, social studies type data where you need to take this huge mass of data that looks intimidating and shrinking it. Whatever the problem is, it always makes it easier to break the problem down. If anyone wants to look at this material, too, I'll put it on a table over here and stick around for a while. This is Computer Science Unplugged. It's out of a place in Australia. It's pretty good. That's like raw computer science for fourth graders, learning to count. And this is a great book under the GPL, documentation license, How to Think Like a Computer Scientist. This version happens to be in Python, but there's a C version and a Java version as well. And because it's GPL, you can write it in whatever you want.
I want to mention one thing. Further questions and discussion on the topic should move to the con suite.
Asking me questions?